Hello everyone, welcome to the next lecture in Theory of Computation, and in this lecture we will be seeing another example of how to figure out what a DFA recognizes. In the previous examples we have seen and learned how to design particular DFAs, and in this lecture we will be seeing, given a DFA, how to figure out what it recognizes. Alright, so let's get started. Okay, so here we have a DFA. We have a DFA over here. We have this figure over here, and we have to find out, or we have to figure out what this DFA recognizes. So just by looking at this, what can we see? We see that we have a starting state here, which is A, and then A on getting input 1, it goes this way, and A on getting input 0, it goes this way. So let's find out what kind of strings does it accept. So first we are in state A, and on getting input 1, it goes to state B. So we get an input 1 and it goes to state B. And in state B, it could either get input 1 or 0. And if it get input 0, it directly goes to D. On getting 0, it directly goes to D, which is a final state. Right? D has a double circle which shows that it is a final state. So 1, 0 is accepted. Right? 1, 0 is accepted. And also, it could come like this. Starting from A, it goes to B on getting input 1. It got 1. And then in B, it could get input 1 again. Instead of 0, it may get 1. So on getting 1, it stays in B. So let's say it got another 1. It stays in B. And let's say it got another 1 again. It again stays in B. So it can get any number of 1s and it stays in B. So let's say it got a few 1s over here out of this state B. And then finally when it gets a 0, it goes to D, which is a final state. It goes to the final state. So this one, how did we get? We got this one from this state A, right? From state A. And these ones, it came from this state B. On running in state B, it got all these ones. So this is from state B. And on getting 0, it goes to state D. So this is also accepted, right? So we found two kind of strings that will be accepted. And then is that the end? No, we have another part over here. So let's check out for this part. Here when we start from the starting state A, and if it gets input 0, it goes to state C. So on getting 0, it goes to state C, and in C, if we get input 1, it goes to state E, right? And it reaches the final state. So this is also accepted. Okay, so how can we generalize this, or how can we summarize and write down what does this DFA recognize? So I can say that this DFA, it recognizes the string 0, 1, or it recognizes a string which contains at least 1, 1. 1, 1, what I mean by 1, 1 is at least one binary digit 1, alright? At least one binary digit 1 followed by any number of 1s and followed by a 0. Alright, so it should have at least one binary digit 1 followed by a 0. So this one is going to be there for sure, and it could either, the next digit could either be a 0 or it could be followed by a series of 1s and then 0. So this is what is recognized by my DFA. So how can I write this down? So this is how I can write it down. L equal to a language that accepts the string 0, 1 or a string of at least one binary digit 1 followed by a 0. So if it comes this way, it accepts the string 0, 1, 0, 1, or a string of at least one binary digit 1, that is this one, followed by a 0. So it could be at least, this I have written here at least. At least means it could be 1 or more than 1 from here, followed by a 0. So this is what is accepted by this DFA. Okay, so far so good. Now let me write down some strings and see what happens when we pass these strings to this DFA. Okay, for example, let me take these strings 0, 0, 1, 0 1 0 0 1 1 1 1 0 1 and 1 1 0 0. Okay, let us just try to pass these strings. We know that these strings were already accepted. Now let us try to pass these strings in this DFA and let's see what happens. Okay, for the first, let me start with this 0 0 1 0. On getting the, I start from my starting state, and on getting the first 0, I come to state C. And what is my next input? 0 again. This is, I'm in state C and I get 0. Oops, now where would I go? I know I should, if I get a 1, I should go here, but if I get a 0, where should I go? I have no more place to go. Is that wrong? Okay, let's check for this string. 0 1 0. I get a 0 and I come to state C. I get a 1 and I come to state E, and then I get another 0 over here when I'm in state E, and oops, again I don't have a place to go. I don't have a place to go. What about this string? 0 1 1 0 1, and when I get another 1, there is no place to go from here again. And what about this? 1 1 0 1 1, and here I get another 1 here. Alright, so far so good. And I get 0 next, this 0 next, and I come to state D and I get 1 in state D. I'm in state D and I get 1, and again I don't have a place to go. What does this mean? Let's check for the last string again. 1 1 0 0 1 1 0, and I get another 0, and from here there is no place to go again. So what is the meaning of this? Where do I, what is this DFA wrong, or where do I send these states to when I get this kind of inputs? Actually, this DFA is not wrong. So what we need to do is we need to complete this by mentioning something known as a dead state. These strings are anyway not going to be accepted. We know that the only strings that are going to be accepted is the one which we wrote here in this L. These are the only strings, and these strings over here does not follow this rule, or does not follow this kind of strings. So these are not going to be accepted for sure. So when we reach a place, a state in a DFA and don't have a place to go, that means that it goes to a state that is known as a dead state. So let us complete this DFA, and I will mention a state which I will call X. And X is what I call as dead state. Alright, X is my dead state, and I will complete my DFA using these dead states. So let us start from here. A, I already mentioned, if it gets 1, it goes here. If it gets 0, it goes here. So A is complete, no need to do anything with A. And let's come to B. B, on getting input 0, it goes to D, and on getting input 1, it stays in itself. So it is okay for with both 0 and 1. It is complete. But for state D does not know where to go, even if it gets 0 or 1. So I will send it to the dead state. I will send it to the dead state. So whether it gets 0 or 1, it comes to this dead state. Alright, now let's come here. A is already complete, and C on getting input 1 goes to state E, but on getting input 0, it does not have a place to go, so we will send it to the dead state. Alright, so on getting input 0. And state E, what happens to state E? State E also does not have a place to go even if it gets input 0 or 1, so we will send state E also to the dead state, either 0 or 1. Okay, now we can check these strings. 0 0 1 0, right? If it gets 0, it comes to state C, and gets another 0, goes to state X, and 1. Oh, our dead state is also not complete. We did not mention what happens if we get 0 or 1 in the dead state. So whatever you get in the dead state, 0 or 1, it stays in the dead state. 0 1. Okay, so 0 0 1 0 0, and in X we get 1, so it stays in X itself. So this dead state is not a terminating state, means it is not a final state. So whatever comes in this dead state is also a non-accepting state, means those strings will not be accepted. Now 0 1 0 0 1 0 goes to the dead state. 0 1 1 0 1 1 goes to the dead state. 1101, 1101 comes to the dead state. 1100, 1100 again comes to the dead state. So X is called our dead state. So this is how you complete the DFA. So if you see an example given without a dead state, or without, when you see that a specific state does not have a place to go, so you should assume that it goes to a dead state. So this is how you complete a DFA, and in this example we have studied how to figure out what a DFA recognizes, and we have also figured out a way how to complete a DFA. So I hope this example was clear to you about how to figure out a DFA and how to complete the state using a dead state.